So this is a kind of snapshot of what's, what the current sort of scientific situation is as regards COVID at the moment. Let's go forward. So basically this, I just kind of gathered a few, kind of questions that various pupils had asked me or various friends had asked me, and tried to kind of put something together to kind of answer most, if not all of those, at least to the best of my ability. So various things like, what's a virus? Is it coronavirus or is it COVID? How dangerous is it? What's the R? I mean, you hear quite often things about, getting the R number below 1 and what that means, whether there'll be a cure, whether there'll be a vaccine. The one that is very dear to my heart is if I've had it once, which I think I have, will I get it again? Or will I be immune?
How long
that
does it
also
take
then
to
goes
recover?
into that also goes into the thing about whether there's likely to be a vaccine, because if you've had it once and if it turns out the people who've had it once are immune to getting it again, then that gives us a lot of hope that some of the vaccines that are under development will actually work.
Adam?
Yeah.
Will you cover how long it takes to recover from it?
Oh, I can answer that at the end, actually, because
can you also cover, like, because some people say corona has like a lifelong effect on your lungs and stuff like that. Can you cover like any permanent?
I will definitely talk about that at the end. So remind me. Definitely remind me. I haven't actually got this in my thing, but it is actually, something that is useful to look at. Okay, but yes, was that Phoebe?
Yeah. Yes.
Okay, so the first thing is people talk about, obviously Donald Trump talks about the Chinese virus, just as kind of like shift the blame for, say it's not his fault that like kind of 90,000 Americans have died. So it's all a Chinese fault. But the question is, do you call it coronavirus? Do you call it COVID? Do you call it COVID-19? What do you call it? And why do you call it that? So the first thing is actually, what does COVID-19 mean? So COVID means coronavirus, COVID for coronavirus, and then so basically the virus that is causing this outbreak at the moment is a coronavirus. But I'm going to come back later to the fact that there are actually lots of different coronaviruses, and so just calling it coronavirus, is kind of a bit useless because there are loads of different coronaviruses. So there is an official name for it, which you probably don't want to remember. But calling it COVID-19 is probably the best thing, though actually that's not the name of the virus, it's the name of the disease that the virus causes. So the D19 comes from, actually I'm sharing if I'm sharing my screen, are you seeing my sidebar as well? Might need to small that. Okay, so it's, COVID-19 stands for Coronavirus Disease 2019. Because it's a disease caused by coronavirus, and it was first identified right at the end of last year, December 2019. That's why it's COVID-19. That's the name for the disease. It's not actually the name for the virus. So next thing is, well, why is it called corona? As in the old, corona, etc. But why is it called corona? And the reason it's called corona is what it looks like under an electron microscope. So basically what you have is this kind of circle with these spikes sticking out of it, which actually shows, a good idea of the shape of the virus.
Is it alive?
The people who first identified a coronavirus,
I don't like it.
In fact, they said it looked like the corona of the sun when you have a total eclipse. So you've got a sort of blank bit in the middle and you've got this stuff outside. But actually the corona, the reason why it's called the corona of the sun is actually corona is the Latin or also the Spanish for crown. So it looks also like a crown looked at from the top. So as I said, corona is Latin and Spanish for crown. Obviously, this is a kind of 2D view, but what people have done is they've done 3D reconstructions of so this is basically just a shadow of what corona looks like, looked at under an electron microscope. But once you kind of piece those together, the actual 3D model, 3D shape, and this is a kind of 3D model of coronavirus, is a ball with basically a ball-shaped thing with all these spikes sticking off of it. And what I'll come back to later is actually what those different things do, at least not in big detail, but little detail.
Stop using. Stop.
Beg pardon? Sorry, I missed that. Yeah, so as I said, it's probably not best to call it coronavirus because there are many coronaviruses. There are thousands of coronaviruses in the world, which infect all sorts of different animals. And there are 7 known, as far as I know, that infect humans. There are four strains of HCOV, human coronavirus. And actually, those are pretty mild. So about 50, when you get a cold, most of the time it's because you've got what's called a rhinovirus, which is a different kind of virus. But about 15% of what you'd call a cold is caused by one of these 4 strains of coronavirus. And actually, they just cause mild symptoms, a bit of a runny nose, and you're fine. And that's because they are proper human coronaviruses, which have adapted to living in humans and really don't want to kill their hosts. Because if you're a virus, the last thing you really want to do is kill your host, because then all of the virus dies with the host that dies. So generally, when there is a virus that is kind of native to a species, the effects that the virus have is fairly mild. And the problems, when you get real problems, it's when a virus jumps from one species to another. So it's adapted in one species to be kind of like a fairly mild thing that gets passed on.
Oh, now? You?
The big problem and the big scary thing is when a virus jumps from one species to another.
Hello?
Hello. I can hear you, but I don't want to. So a lot of the kind of scary viruses around at the moment, things like Nipah virus, things like Ebola, things like HIV, are viruses that have fairly recently jumped from another species where they don't cause very much in the way of serious symptoms into humans, and because they are essentially the wrong virus in human, for working kind of well with human cells, they start damaging things. So that's when you get one of these worrying viruses like the current COVID outbreak, like HIV, and like a couple of other coronavirus outbreaks that happened over the last 20 years or so. So the other 3 coronaviruses that infect humans are SARS coronavirus, and that seemed to have jumped across from bats in about 2003 and caused an outbreak of what was called SARS, or severe acute respiratory syndrome, in Southeast Asia. And there were about 8,000 cases of it, and about 10% of them died. There was another one that seemed to have come across in the Middle East from either bats or possibly camels, and that was called Middle East respiratory syndrome. And there was another outbreak. That's a misprint. It was about 2013, not 2003. And there were about 2,500 cases, and actually almost a third of those people died. So the kind of good news is that the most recent one that jumped across is the one that causes COVID-19, and it's nowhere near as deadly as those. So just going back to what a coronavirus is and what basically a virus is, first thing to think about is that you can't kill a virus. You can inactivate a virus. And the reason why you can't kill a virus is because basically viruses aren't alive. Viruses are just little payloads of genetic information that can, when they get inside a cell, hijack the functions of the cell and make it make more virus. So a virus on its own can't divide. A virus on its own doesn't eat, it doesn't grow, it doesn't do anything. It's just inert until it gets into a cell, at which point it hijacks the cell and says, make more virus. So they can't reproduce and grow on their own. They can only make copies of themselves by hijacking a host cell. And I think, and if they basically make too many copies of the virus at the expense of what their host cell is supposed to be doing, that can kill the host cell. And obviously, if you start killing a lot of cells, a person gets sick. So I've got here, and I hope I might have it as an animation. So I'm just going to do a quick animation of virus life cycles. So if I go onto this and do...
It's so creepy looking. I don't like how this spherical thing is just alive.
Yeah. So I'm just checking. Are you seeing my full screen? So can you see... I'm now going into Firefox, or is it still?
No, you have to stop screen sharing and reshare your screen to a different one.
Okay. Yeah, because sometimes PowerPoint sort of just kind of hijacks it. Okay, now can you see my screen?
Yes.
Okay, so basically this is just a little animation. So there are various different kinds of viruses, like retroviruses, which cause things like HIV is one, DNA viruses, things like cytomegalovirus, which causes glandular fever. Can't remember. There are single-stranded RNA viruses. It's all down to what their genome is, and they include some of the ones that cause hepatitis. But the coronaviruses are single-stranded RNA viruses. And basically, what happens is there you have a single-stranded sense RNA that basically gets into the cell and makes the cell produce proteins that the virus wants rather than what the cell wants. So the virus will attach to the outside of the cell. It will usually fuse with the cell, or it will squirt its RNA into the cell. That virus RNA gets loaded onto the ribosomes in the cell, which make protein. And that makes more virus protein. And also makes things that make extra copies of the virus RNA. So you can see extra virus RNAs being made. And then these get packaged into new viral proteins, which are also made by the hijacked cell. And then those viruses burst out of the cell. Sometimes they'll leave the cell intact, but most of the time they will kill the cell. So essentially, the virus on its own doesn't do anything, but once it gets into a cell, it hijacks the cell and gets the cell to make more viruses. Okay, if I now go back onto PowerPoint, play from current side. So can we see my PowerPoint again now?
Yeah.
Good, okay. So the viruses, they're not alive. And basically the structure of a coronavirus, so this would be a sort of, the thing at the top is like a 3D view of it. The thing at the bottom is the section, kind of a slice through it, but it also shows you why it looks like this crown view from above, because it's got all these spikes, it's got a sort of circular middle bit with all these spikes sticking out of it. And I'm not going to go into mad detail about it, but basically there are three important things about this. You've got in the middle, you've got the genetic material, which is the RNA. And what that does is when it gets into the cell, it tells the cell to make more virus. The next thing they've got is the thing that's called the envelope, and that basically protects the, it's a sort of bag of membrane that the RNA is contained within. And actually it's a bit of membrane that's been stolen from the cell. Key thing here is because it's one of these envelope viruses, it's actually quite easy to destroy because that envelope can be destroyed by detergent, it can be destroyed by alcohol. So actually a lot of the disinfectants...
Is that why Trump suggested drinking bleach?
Exactly. So Trump put 2 and 2 together and got about 20. And basically he realized, he'd been told that bleach will kill or will inactivate coronavirus. So therefore he said, well, why don't we use that in people or various disinfectants? He got mixed up between disinfectants and antibiotics, I think is what he said. Well, it was basically his problem. So disinfectants usually contain either bleach or detergents or alcohol or some mixture of them. And all of those can break up the envelope of the coronavirus and basically inactivate it. So it's fairly easy to inactivate, but the tricky thing about the envelope is it also makes it quite easy for it to get into cells. And if it isn't inactivated, it can get in quite easily. But it only infects some cells, and it only infects the cells where it can stick onto the outside of the cell using the third component, which is its spikes. And the spikes on coronavirus are able to bind to some proteins on the outside of cells in your respiratory tract, so in your lungs and in your airways. But also, and this is the interesting thing, that those surface receptors are found on some other cells in your body. And it's still not clear whether the reason why coronavirus kills you is all down to what it does in your lungs, or whether it's because it also gets into other cells in your body. And there's research still going on about that, and I can't give you an answer on that. Because I don't know, and I don't think anybody else does. So the question is, okay, right, how dangerous is it? How worried should we be about it? Well, basically, for the rest of this, presentation, I think you can take anything that Donald Trump has said and say, essentially, it's the opposite. Or at least that is completely wrong. So, for example, he said, it's just going to blow over, it'll disappear in April, it's no worse than the flu. Well, there's good news, which is the mortality rate, which is the death rate if you get infected with it, is about 0.5%, which is way less than SARS, which was about 10%, or MERS, which was about 30%. So it's not, most people who get it, 99.5% of people who get it survive. But the bad news is it does seem to be spreading pretty well. So, according to kind of the various things like the CDC, Centre for Disease Control, around about 1 million people, about 950,000 at least. 950,000 people at least have died worldwide. It's a bit hard to tell because the record keeping is different in different countries, but it's probably around 1 million, which compares, Mr. Trump, with a typical flu outbreak that kills around about 0.4, 0.5 million people in a year. So that's 1 million in 9 months. And the bad news also is that it's not petering out. It's going to new countries. It's still spreading. So this is the death rate around the world. And it's sort of like popped up, you got the initial sort of start in, kind of the Far East. And then as it spread to Iran, Europe, and around China, it started going up, and it started spreading to other countries. And as some countries managed to level the curve up, new countries came in and new countries came in. So the death rate is pretty much kind of bouncing around constantly at the moment. It's not stopping. And the slight worry is when it gets into countries, particularly, the big worry at the moment is India, where India and South America, where rates are going up very, very rapidly, and a lot of people living, crowded slum accommodation, and that can spread very quickly there. So that's the big worry for global deaths, if not for deaths in Britain. So 0.5% of people who get it roughly will die, but it's not spread evenly. So if you look at it divided by age range, and so this is a slightly complicated graph because they've done it from 4 different countries because they count things in different ways, but just to get an overall view. And basically, the people I'm talking to at the moment, most of you have nothing to worry about. I would say it's not unheard of for somebody in their teens to die of COVID-19. There is somebody in year 11 who actually knows a family where somebody died of, who was a teenager who died of COVID-19. So it doesn't never happen, but it's pretty rare. So so up to about 50 years old, your chances of dying, even if you get COVID, are fairly low. But from about 50 years onwards, it goes up rapidly. And obviously, the thing is, partly it seems to be something to do with age. Partly it also seems to be that the older you are, the more likely you are to have a heart condition or diabetes or high blood pressure or various other ailments, which do seem to contribute to the likelihood that COVID will kill you. But it's not just that it kills people who are going to die anyway. They've worked out for the people over the age of 60 who do die of COVID, they would on average have expected to have lived another 11 years. So it's not just, there was initial thought that maybe all it's doing is killing people who are going to die anyway. No, people over 60, they are still losing, when they die, they lose about 10 years worth of expected life, even if they had got diabetes or something like that. So it is kind of bad. So basically, the thing, for you, the major worry, I think, for somebody who's of school age is not so much that they themselves are likely to die of it. It's that they are likely, A, to feel rubbish, but B, also potentially pass it on to people who could die of it, like their teachers or their grannies.
Die a bit.
So there was a lot of, they keep mentioning this in the news, and basically the idea is, we need to get the R number down. And I wasn't, some people seem to, kind of get it straight away, but I thought I'd just kind of quickly mention it, which is that basically the R number is if you have a person who has the disease, on average, how many people will catch that disease from them. So if your R number is 1, it means that if you've got a disease, on average, 1 person will get it from you. If the R number is above 1, it means that if you've got the disease, more than 1 person will get it from you. And if it's below 1, it means that fewer than 1 person, on average, will get the disease from each infected person. And looking at the stats, basically what is called R0, which is the R number if you take no precautions whatsoever and the whole population is susceptible and nobody's immune. It looks like the R number for SARS-CoV-2, which is the thing that causes COVID-19, is about between 3 and 4. So each person, in a totally susceptible, no precautions environment, each infected person will, on average, infect 3 to 4 other people, which means that if each of those 3 to 4 other people infect another 3 to 4 other people, which infect another 3 to 4, the number of people infected will go up very rapidly, and it will go up exponentially. The good news is that with control measures such as social distancing, patients isolating, wearing masks, good hygiene, it's reasonably possible to get that number down to 1 or below 1. And the reason really why you want to do that is because if you get a big peak of coronavirus infection, you're going to overwhelm the hospitals. You may not be able to eradicate it completely, but if it really takes off, A, a lot of vulnerable people will get it, and B, the number of people wanting admission to hospital will go up so much that not enough people can get into hospital. So that's why it's important to keep that R number down near or below 1. And that's what the various measures that the government has brought in, some of them logical, some of them illogical, are intended to do. And some of them I think have worked, some of them haven't. I'm not going to comment too much politically. I think there's been some inconsistency there. So the next thing is how is it transmitted? So how does it get from one person to the other? And it appears that at least 90% of it is airborne. It's by droplets that are coughed or sneezed or accidentally sprayed out when you're talking. And so that photograph is actually, it's a real photograph. It's not like kind of Photoshop or something like that. What they do is they backlight, and that's somebody, I think they're coughing rather than sneezing. And as the backlight hits the little droplets, you can see how far those droplets go. They go kind of, probably at least a meter. So that's the main thing that we want to be sort of, to get the R number down, we need to stop that airborne transmission. There's only very limited evidence about it being transmitted by touching surfaces and then somebody else touching those surfaces. But because there's not a great deal of evidence for it, I think it's worth being on the safe side and doing what we're doing at school of wiping desks down with disinfectant, wiping phones before you lend them to anybody, all that sort of stuff. It's worth doing just to be on the safe side. I don't know whether it is having an effect or not, but it can only have a good effect and it's not going to have a bad effect. But the main thing and the main way that coronavirus gets from one person to another is by droplets that people sneeze or cough, or just a little spray of droplets that actually comes out of your mouth just when you're talking. You may not be able to see them, but they do exist. And putting that together with the likelihood of people in your generation actually dying of the disease, it basically boils down to wearing a mask is largely not to protect you. It may, the kind of disposable masks that we have really don't stop much coronavirus coming in. If you wanted to do that, you'd have to have a proper respirator like they use in kind of isolation units in hospitals. But what wearing a mask does is it protects other people around you. And some of those other people around you are people who may, even if you don't know it, be in vulnerable groups, or may be people who could pass it on to people in vulnerable groups. So, for example, I think I'm probably not in a vulnerable group because I think I've had it already. I don't have a heart condition. I've got very slightly high blood sugar, but I'm not diabetic. I am probably okay. But I'm also in a bubble because I am helping look after my soon-to-be ex-wife who's having cancer treatment at the moment. So what I'm worried about is not that I'm going to die of it. What I'm worried about is that if I get it and pass it on to my soon-to-be ex-wife, then it may either kill her, which is possible but unlikely because she's probably still reasonably robust, but at the very least it would mean that she'd have to stop her cancer treatment, and that could have a serious adverse effect on her. Other people, though you may not know it, are living with people, they live with their granny or something like that who's 80, who is at high risk. Once you're over the 80, you've got about a 10% risk of dying if you get COVID. So wearing a mask around the school, wearing a mask on public transport is not really mainly to protect you, because many teenagers children and teenagers can quite often be infected with COVID and not even know because the symptoms are so mild. But while they have it, they can pass it on to other people who may themselves be vulnerable or can pass it on to other vulnerable people. So, next thing, will there be a cure? Well, you could inject yourself with disinfectants. You can shine ultraviolet lights on you. You can take hydroxychloroquine, or you can take, what was the other thing he took? Azithromycin, which is an antibiotic, which of course, as everybody who's done GCSE biology knows, antibiotics don't kill viruses. So there's a lot of nonsense talked about, mainly by the President of the United States, about things that might cure coronavirus, as in a drug that you will be able to take if you have coronavirus, and it will stop your symptoms or stop you from dying. There are a very few antiviral drugs that are being developed for other viruses that seem to have a slight effect on coronavirus. But my kind of take-home message is not any time soon. There are some existing drugs. There's one called remdesivir, which have a very limited ability to shorten the length of the illness. But the latest trial said, shorten the illness from like 14 days to 11 days, but it didn't actually affect the overall death rate. So there's nothing that's going to, there are no magic cures at the moment. There are plenty of investigations going on, but there are no magic cures at the moment. And my guess is it won't be for a few years yet, because actually antiviral drugs are very difficult to develop, because almost everything that is done to make the virus is done by the host cell. It's not done by the virus itself. So you've got to find some way of specifically targeting the only the things that happen in a virus-infected cell, but not happen in a normal cell. And most of 99.99% of those things are the same between a viral infected cell and a non-viral infected cell. So it's really difficult to find targets for drugs. So it took about 10 to 15 years to develop any drugs that were particularly effective against HIV. Took about 5 years to develop Tamiflu against flu. So my guess is it's probably going to take 5 to 10 years before there is a cure, a drug cure for COVID. So I'm not going to hold my breath. But there is hope. And that hope is immunity to the virus. And that's one I'm got my fingers very, very firmly crossed for, which is, a lot of people have said, and I have said, if I've had COVID-19, am I now immune to it? And the there's only a tiny bit of data because it's not been around for long enough. But my answer to that is probably.
I don't know what time it is. I don't.
Sorry, I can't hear you.
I stopwatch to tell me it's break time. Take them up.
Okay, so look, I'm on here.
It would have been nice. The lowest year nice and more down here. I know, that's what I thought. Can I?
Oh, sorry, I can just hear Sigrid chatting in the background. Okay. Okay, right, so the answer is basically probably.
Oh, what a good girl. Belle's on from China. You've mocked her accent.
Sorry, guys. Sorry, I can hear a lot of chatting on here. Sorry. Could you mute yourself, Mina?
Here.
Okay.
Mina, can you mute yourself? Mina, can you mute yourself?
She can hear you. I'm Sigrid. Sorry.
Oh,
I don't know if I can mute me. Okay, yeah, Mina's now muted. Okay, that's good. Okay, so my answer to that is, with the limited amount of data there is around, the answer is probably. There are a few cases where people seem to have got it twice, but certainly the second time they've been able to detect the virus, but they've not been able to see any disease. So that's sort of what you would expect, actually, if people were immune. So that's very pleasing because A, it means that gradually the population will become more immune, so fewer people will be passing it on. That's called herd immunity. But also it makes us confident that an effective vaccine will be produced. And that is the bigger hope than actually finding a drug. Sorry, this is my little joke, little meme I found. Somebody needs to chuckle.
It's funny, and I was laughing, but I was
Excellent,
muted.
good. That's all I needed to know. That's all I needed to know. Which is that basically, so how long, how soon are we going to get a virus? Once again, let's ask the fount of all knowledge. Donald says sooner than the end of the year. Could be much sooner. Could be sooner than November the 3rd, which is the American election. So he's obviously very keen on that. Actually, no, probably not. But the good news is basically there are about 300 candidate vaccines in various stages of development, of which about 50 are in trials, clinical trials of some sort. But the initial clinical trials are basically just looking at initial safety rather than whether it actually protects you against against SARS-CoV-2. But there are now 6 good candidates in what are called phase 3 trials. So phase 3 trials is where they try it on a lot of people. They don't just, it's the last thing they do before they release it to the whole population. So there are these, 5 promising candidates plus 1 dodgy Russian one, which they seem to be pushing through without proper trials, so that Putin can say he's got the vaccine first. It's slightly worrying they are pushing that through too quickly, and it's almost certain that there will turn out to be some problems with it. But of the other 5, which include the one from Oxford University, Oxford Biomedica, that's been done by AstraZeneca, they're all in phase 3 trials. The AstraZeneca one has been paused briefly because they had 1 adverse reaction that they're investigating. But that could, when you're testing on 3,000 people, could just be a totally random thing. So I'm not going to, they will almost certainly, investigate it and restart it.
Can I ask a question about the vaccine?
Yeah.
It's been said, how will we know that the vaccine could not have some disastrous side effects that don't develop months or even years after you take it?
Right. You cannot know about delayed side effects. What you can do is you can look at how people respond to it in the short term and see if there are any hints that there would be long
But how do we not know that it could destroy our lungs in the course of 2 to 3 years or something?
I can think of no mechanism by which a vaccine would destroy your lungs.
No, just hypothetically, something as catastrophic as that.
It is not impossible, but so phenomenally unlikely that I'm not going to worry about it.
Okay. That was worrying.
There are, and that is essentially what is intended, at least, it's almost impossible to see what a long-term, a 10 years down the line effect.
Because, there is a risk. You're literally injecting part of the virus into you.
There is. But basically, what happens is you do the stages you do what are called preclinical testing, where you test it in cell lines in an animal model to show that it's not harmful to the cell lines of the animal model. Then you do phase 1 trials, which is where you give it to healthy people, just to check whether it kills them immediately. Basically, it's in any way toxic. If it passes a phase 1, it goes to a phase 2, where they do a slightly larger population, and A, see whether it does them any harm, and B, see whether it does them any good. But that small population, that phase 2 trial is usually, it may well be a bunch of, kind of 20-year-old students. And then in a phase 3 trial, what you do is you test it then on people of different sexes, different ethnicities, different ages, in a big trial of several thousand people, to see if there are specific groups who have more side effects than others. And it's only once it's passed the phase 3 trial that they then apply for licensing to release it to the population as a whole. Now, what I would say is you cannot guarantee that those people with the phase 3 trials, if they all suddenly die 10 years later, there's not much you can do. But the likelihood.
What if like half the population just dies 10 years later?
Then there's absolutely nothing you can do about that, and that would be a worrying thing, but it's kind of unlikely, because obviously what is done when you're designing a virus, well, designing a vaccine, is to have multiple safeguards to make sure that it doesn't produce live virus or anything like that. So there are lots of safeguards along those lines, and basically, in general, you can't, you can never say never, but vaccination has proved phenomenally safe. It's been going, for thousands of years in China, and 300 years in the Western world, and there has been very, very little evidence of any harm, and certainly never any harm that outweighs the benefit. So amongst medical treatment, vaccination is one of the safest, and it's generally safer than most drugs. So I wouldn't worry about that. Quite honestly, you have my word for it. I would never worry about vaccination.
Oh, good.
So, okay, the Donald reckons before the end of the year. I would say realistically, with the possible exception of the Russian one that they're rushing through in a slightly foolhardy way, I think. Probably just because of Putin's ego, I would say before you're going to have mass vaccination, it's going to be early to mid 2021. So I think we're going to have to hold on at least till the new year before there's a proper vaccine.
I was expecting longer though. Some people said not until 2022. Some said not until 2024.
It's not impossible. It very much depends how these phase 3 trials work. And whether those then show protection, whether those then show good antibody counts, good T cell response. So, if that all goes smoothly, we're looking early to mid 2021. If side effects are uncovered in the phase 3 trials, or it turns out in phase 3 trials it doesn't work as well as they think it did, then it could be delayed by a year or more. But fingers crossed, seeing as there are 6 of them. My hope is at least one of them will come through good. So I'm not going to hold my breath, but I think I'm reasonably hopeful it'll be sometime next year. Okay, this is one of the things that kind of I'm sort of jumping off that is the where did it come from thing, which there's been so much rubbishy internet conspiracy. Sorry, I'm not going to swear. Purveyed by, our old friend Donald Trump, for example. I have high confidence, but I can't tell you why, that it came from a laboratory in Wuhan. There is absolutely no evidence that there was any genetic engineering involved, definite. It's not totally beyond the realms of possibility that it was a sample that did get dropped in a lab in Wuhan that had come from somewhere else. It's not impossible, but the lab in Wuhan is a level 3 facility, which is like kind of Fort Knox. It is multiple layers of isolation because it's a top virology facility. It was built by a sort of Chinese and French consortium. It is state of the art. And the thing that really annoys me about this is that basically he pointed a finger at this woman called Zhengli Shi and said, oh yeah, she must have collected this virus from somewhere and then had it in her lab and it escaped. She is a hero in this story. She was the woman who basically said in 2014, there are these viruses in bats which can potentially get across into people, could cause an epidemic. They are a bit scary. We should be planning for it. She's a hero in this situation.
Right, so she predicted it would happen all the way back then?
Yeah.
Wow.
Because she was collecting, she's a virologist, and she was collecting, coronavirus samples from various bats and other animals around Britain, around China. She was one of the people who campaigned to stop the use of bat products in traditional Chinese medicines, which, to my mind at least, is the most likely place where it jumped across. So I think she's a hero. It is not impossible, but there's also further evidence that the strain that came, that is causing COVID is not a strain that's been published by her lab. So she has published thousands of, kind of sequences of different viruses, publicly published those. None of them are the same as the one that is causing COVID. So it's quite likely she would have, and this is what you do as a scientist. When you sequence something, you don't just, you don't wait and put it in a paper. You stick it on a database, on one of the big databases. And she has been consistently putting any viruses that she's discovered on those databases. And the one that is causing COVID is not one of those. So the place it most likely came from is crossing from an animal host, and the most likely animal host is horseshoe bats. There are lots of horseshoe bats. There's a lot of limestone caves in Hubei and Yunnan, which is the area where it seems the infection seems to have originated.
Could I ask a question?
Certainly.
Have they tested various animal species to see if the virus naturally occurs in them?
They have, and what they've found is the closest related virus. They've not found that exact virus in any bat or other species. The closest ones they've found are sequences in bats and also in pangolins. So there's a little bit of controversy about whether it went pangolin bat human or human pangolin bat or just bat human. But the closest related viruses that they found were in bats, and the next closest related were in pangolins. And the initial finger actually pointed at this place called the Wuhan Wet Market, which is basically a big fish market that also sells exotic animals. It now looks like that wasn't the original source, because there were, at the same time, people who were going into hospital in Wuhan who'd never been to the wet market. But it did look like there was a considerable degree of spread amongst people who used the wet market. So it looks like that this was one of the big sites of initial spread, but not the source, because other people were getting diagnosed at the same time who'd never been there. So it implied that there was somebody who was like a source who'd maybe moved to Wuhan from somewhere else, perhaps, who had started it in Wuhan, and then it spread within the wet market, but it also spread in other populations. I said, the Donald's view is it was the Wuhan Virology Lab. It's not impossible, but it's extremely unlikely, basically based on the fact that it's not one of the viruses that she's published. It's and the virology lab there is like a category 3 containment facility. It's got so many isolation things that, it's very unlikely anything will get out. It's not impossible. I'm not going to pretend it is totally impossible, but it's unlikely. The strongest evidence, probably the strongest hypothesis, is that there were a couple of people who were from the countryside in Hubei and Yunnan who were also diagnosed around about the same time. And it's quite common in traditional medicine, particularly in the countryside in Hubei and Yunnan, to use, it's kind of unpleasant, but they use ground up bat feces and sometimes bat tissues in traditional medicines. And there's one that's there's a medicine for eye infections, which includes amongst its ingredient bat feces. And the eyes are obviously a fairly thin, layer of skin, and it's fairly easy for stuff to get through that way. It's also easy to, when you're grinding stuff up, inhale powder. If you're a traditional medicine guy who's got some dry bat feces and they're grinding them up in a pestle and mortar, you will generate dust which quite possibly has virus in it. I think that is the most likely thing, is that somebody in the countryside in Hubei or Yunnan, which is where these bats live and is close to, Wuhan is in Hubei province and Yunnan is next door, that somebody picked it up in the countryside, visiting bat cave, making bat feces medicine, then travelled perhaps to go to the wet market or just visit friends in Wuhan and infected a bunch of people there. That is the most likely thing. Oh, and that reminds me, there was one question that somebody asked me, which I haven't put in here, which is, how do you tell, how related they are? And that is that basically viruses mutate. And so you can look back and see what the last common ancestor of two strains of virus is by seeing, okay, what different bases have mutated. There was a worry at the beginning of the outbreak that it might mutate to be spreading fast, or the virus might mutate to be more deadly or something like that. All of the evidence is that the coronavirus mutates very, very slowly. It's one of the most stable viruses, unlike something like HIV, which changes really quite rapidly and changes rapidly enough for vaccines that work on one strain not to work on another. It looks like coronavirus is basically staying pretty much the same as far as all the evidence is at the moment. I'm not going to say it can't change, but at the moment it hasn't changed very much. And that's what allows you to trace it back and say, it's very similar to this bat virus, and it probably crossed from humans to bats in the last year or two. Right, was that the... right, yeah, no, I just threw this in right at the last moment because it's kind of topical, because apparently our dear leader is going to go on the TV at 8 o'clock and announce tightening of lockdown measures. And...
Wait, are these tightenings happening for sure?
I don't know, you have to watch the news at 8 o'clock. But it's been leaked that they're going to have pubs are going to close at 10 and things like that, and there might be some other things as well.
All I'm concerned about is there going to be a second lockdown?
Basically, so what's happening is the R number has gone up. So basically, if you look at the left here, the blue graph, this shows the number of new cases per day. And it started off low, and in the sort of peak of the beginning of April, May, we were getting like 6,000 new cases a day. Then it went down, and it bottomed out in the middle of August, or thereabouts. But it's sneaking up again. Now, it's, from this graph, it looks like it's as bad as it was in April or something like that. No, it's not going up as quickly. And also, more cases are being identified because there's more testing going on. So don't panic about it, because if you look at the graph on the right, which is the number of deaths per day, those peaked around the middle of April and have been going down since. And then they've been troggling along at about 5 or 6 a day. If you were to look, they've actually kicked up very, very slightly over the last week or so, if I remember rightly. So it's enough to say, okay, need to put the lid on it now before it starts going back to how it was before. But I think so there will be some new measures announced tonight, but that doesn't mean it's something to panic about. It's not the second wave. It's keeping the R, basically the R number is crept above 1, and basically you want to keep it down near 1 so that the number of cases stays the same or goes down. If it gets above 1, then you have the possibility of it rocketing back up again. So that was basically what I was going to say. And I don't know who is still here and if anybody has any questions. Were there any later?
Yeah, I had some.
Dokes. Okay, so I have, as far as I can tell, 2 questions. One saying, sorry, I'm late. Okay, so Phoebe, yes, far away.
Okay, how long does it take to recover from COVID? AKA, like, if you have the symptoms, you test positive, and you go home and self-isolate, how long before you can go back to normal
Right,
life?
it depends. I guess it depends on the severity and the viral load. If you have a fairly mild case, it looks like you cease to be infectious after about 10 days. If you have a more severe dose, it can take up to 2 weeks before you're not infectious. So you should really isolate during that period.
Uh-huh.
How long it takes to recover is a very much unknown quantity. What I can speak from personal experience, assuming that I did have it back in April, March. In fact, it was end of March when I had to take 3 weeks off work. I felt like absolute crap, coughing all day and all night. I didn't have a temperature, so I didn't tick all the boxes, but not everybody ticks all the boxes. I am 90% sure I had it then. And actually, I'm still not up to 100%. I still get a bit breathless. I still get a bit fatigued. I still a bit achy.
So it does have a long-lasting effect.
So it does seem to have a long-lasting effect. And that seems to be increasingly coming through from, both anecdotal stuff and, more medically kind of things that on some people, it depends on the person. It seems to be fairly random, but it can have a long-term effect. What I would say is it's having a long-term effect on me, but I'm still way better than I was a month ago or a couple of months ago, which is way better than I was 4 months ago. So it's getting better, but it's taking a while. There are people, and certainly there's evidence from this MERS, the SARS outbreak and the MERS outbreaks that some people do have long-term health effects from this type of coronavirus.
Is it likely people our age would have those effects?
I do not know. I think, I don't know what the evidence is, so it would not be right for me to answer that.
I have another question if no one else wants to ask. Do you think that there is a chance that, like, before the vaccine, like, the virus would, like, not completely go away on its own, but, like, go down enough to loosen measures and stuff?
Right. I think a lot of this will depend on the results that they get from the tests they're doing to find out, they're doing a bunch of surveys on how many people have actually got antibodies to it. Because it would appear that a lot more people, from very limited studies, a lot more people have had it than have been diagnosed with it.
So you could have had it without even realising and then have antibodies.
If a bigger part of the population have already had it and are to some extent immune, there is the potential that it will die down as, say if 30% of the population are immune and have had it but don't even know, and basically these studies are being done at the moment, then what will happen is the R rate will go down because there will be fewer and fewer people to infect, and it will die out naturally. It very much depends on how many people have actually had it and how many of those people become immune. Mm-hmm. So that's sort of what happens with measles outbreaks, for example, or used to happen before vaccination, is that there will be an outbreak, but it would spread really quickly, and then eventually enough people will be immune to it that it will stop spreading and die out again. So there is a possibility that it may burn out of its own accord if people who have had it are immune to getting it again, and if more people have had it than we think have.
Okay, can I ask another question?
Certainly, unless anybody else wants. Has anybody else got another question before Phoebe asks another one? No? Okay, you're good.
Okay, this isn't really like too much related to COVID rather than related to, the COVID protection measures, but do you have to socially distance from people within your own bubble? Like 2 meters?
No, if you're within a bubble, it is assumed that you are actually you've already been in enough contact that you will, if they've got it, you're going to get it.
So I mean, like, it's good to be safe, but like you can sit next to each other and stuff.
Oh yeah, if they're in your bubble, you are fine.
Okay.
I mean, certainly if it's a bubble, a family bubble, it's a little bit. I do not think they thought through the going back to school thing properly. To tell the truth.
Yeah, I think in my opinion, it's rubbish for them to go to all this effort of opening schools for pretty much 50% of them to just immediately shut down after 2 weeks.
Yeah, exactly. I think the school thing should have been phased in a better way.
Yeah.
Both by the government and by the government.
Me as well.
And there could have been better ways of doing it. I think there could have been a better way to come out of lockdown, but that was just my mad idea. But and nobody would listen to me. My idea was that young people should be able to go back to work, but old people would have to stay at home.
What do you mean by young people?
Well, no, my idea is that they shouldn't, if they were going to ease lockdown and open the shops, what they should have said is that you can go and work in a shop if you are under the age of 40 and don't have anybody over the age of 80 in your household.
Oh yeah, that is a good idea.
That would have worked nicely, but nobody asked me. So the government didn't choose to ask some biology teacher. But
maybe some politicians thought the same though.
Yeah. I mean, there's been a lot of muddy thinking, and I think there's still not an absolute strategy about how they think it's going to end. But they're hoping that something will turn up. But I think at the moment, it's reasonable to squeeze the lockdown in a little bit more, just to nip that in the bud. But in general, I think things are getting normal-ish. But I think there've been some very inconsistent guidelines, like you can go and be in a class of 30 people, but you can't meet 6 people in your family, for example. It's a weird one. So, do I have any more questions? No? Okay, well, I will wish you a lovely evening, and I think we've actually overrun anyway.
Thank you so
Thank you very much. It was really informative.
Thanks.
Thank you.
Brilliant. Well done.
Goodbye.
Bye.
Bye. Okay. Stop recording.